everybody, we're going to pick up with muscular system and the study of a myogram. This information comes from your course pack on page 88. Now, to explain, a myogram is a measure of muscular activity. So we're going to talk about muscle tension first. Muscle tension is produced when cross bridges take place. So I need to ask you, what is a cross bridge? Well, a cross bridge occurs when a myosin head, you might recall those, from a myosin filament, reach up and anchor themselves to a binding site on one of these actin filaments. Okay, so we know that portion there, this linkage of the myosin head to that actin binding site, that forms a cross bridge. Okay, so that's what we expect to see as the head bind to the actin filament, the cross bridge is formed, and sometimes our muscles are in a constant state of cross bridge formation. For instance, whether or not you realize it, you actually have to keep a mild state of muscle tension in order to keep from falling out of your chair. So some muscles are always at a mild state of cross bridge formation. In other words, when cross bridges form, they actually create a set of muscle tension that keeps those muscles somewhat stimulated and constantly contracted. So if you want to increase the tension in a muscle, you can either do one of two things. You can increase the frequency of the muscle stimulation, or you can change the number of muscles being stimulated. We'll talk about that as we work through this image and others. What you're looking at here is called the phases of a muscle twitch. We're going to start off with a stimulus at the very beginning here, and that's when the nerve impulse arrives at that muscle. Well, let's go back through those steps. When a nerve impulse arrives at a muscle, we know that acetylcholine must be released into the synaptic cleft. Acetylcholine binds with a particular kind of protein channel called a sodium channel. Sodium channels open, and of course sodium rushes into that muscle cell, changing the environment to a positively charged environment. All of that happens here during this excitation period known as the latent period. We know now that the SR responds to this excitement by releasing calcium. So as calcium is released from the SR, we now enter the contraction phase. The contraction phase occurs as calcium enters into the sarcoplasm from the sarcoplasmic reticulum. It allows for the myosin heads to bind to those actin filaments because calcium binds troponin and moves the rope of tropomyosin away from those binding sites on those actin filaments. So cross bridge formation occurs, and the sliding and moving of that muscle occurs all during this contraction phase. Look how quick this is. This is milliseconds of time. We finally have the relaxation phase follow up. That's when the calcium levels fall and the calcium is restored back into the SR, or the sarcoplasmic reticulum. When the calcium disappears from the sarcoplasm and returns to the SR, then those tropomyosin ropes recover the binding sites on actin filaments. Cross bridges are no longer possible during the relaxation phase. Notice it takes longer for the muscle to relax than it did for it to contract. So all of this, from the excitement of the stimulus to contraction and relaxation, is all less than a second. Okay, so we're dealing in time here of a millisecond simply for a muscle twitch to occur. At the peak of contraction, that's when we see the highest level of tension occur in that muscle. So in order to increase the strength of a muscle contraction, we can actually change either the frequency and or the number of muscles being stimulated. This myogram shows us that if we increase the frequency of stimulations, that we can actually increase the tension of the muscle contraction. These arrows along the bottom illustrate a muscle being stimulated. So you'll notice that a single muscle stimulation is called a twitch. Now that's not the normal way for a muscle to respond to a nervous system stimulation. So this may indicate that there is some issue going on. Perhaps you're tired, perhaps you're stressed, perhaps there's something else going on with the nervous system that causes that twitch. Now, Treppy is next. You'll notice that we now increase the number of stimulations. They come a little more quickly, and every time we stimulate that muscle, we end up seeing an increase in the tension there. okay? But these stimuli don't come fast enough. In other words, the frequency isn't quick enough to maintain muscle tension. That muscle has an opportunity to drop back off to a relaxed state before it's contracted again. It relaxes yet another time before it contracts again and then falls back off to a relaxed state. So we don't normally experience much with Atrophy, but we do here with summation of twitches. That's what we normally experience when we can produce a muscle movement that actually produces some kind of function, like flexion or extension, picking up a book, pulling off your socks. Those kinds of things will result from a summation of twitches. Notice again, each of these arrows indicates the stimulation coming a little more quickly, and since we're increasing the frequency of stimulation, we give this muscle less of an opportunity to fully relax between stimuli. Instead, what's happening to the tension over here? Well, the tension tends to increase, and that's what we're trying to do when we have a summation of twitches. What we don't want to experience is the last set. This is called fused or complete tetanus. Notice the arrows here indicate that we are getting stimuli so fast that there is no opportunity for the muscle to experience a relaxation state. Instead, the tension increases and there is a complete or fused state of tetanus. Now, that's actually very uncomfortable because your muscle has no opportunity to relax. Also, we see that other muscles are recruited here, and that increases the tension in this muscle. So if you've ever had a muscle cramp or a Charlie horse, you may have experienced fused or complete tetanus. It's pretty painful when we get to that state. So incomplete or unfused tetanus is what we often think of as summation of twitches. Okay, so that is where we're going to reach our peak tension that's not painful. Just wanted to show you some pictures here for further explanation. If someone has fused or complete tetanus in a lockjaw situation, that may result in painful muscle contractions, not just in the jaw area, but all over the entire body. This can come from a bacterium called Clostridium. So we've often heard not to walk in the yard barefoot, for you might step on a rusty nail. You can actually pick up Clostridium not only from rusty nails in your yard, but also from the soil. So if you have cuts on your hands or feet and you work in the soil, Clostridium can enter your bloodstream through those cuts. Now, back in the day before we had antibiotics, this was a painful condition that you either lived through until your immune system conquered those bacteria, or you died from the overwhelming bacterial infection. Nowadays, we do have antibiotics that can help to defeat this Clostridium bacterium. We also have tetanus shots that can prevent this tetanus condition from developing. It prevents the toxin from Clostridium from building up in our bloodstream. Now, black widow spiders can also produce tetanus due to increased acetylcholine release. If you think about this, let's draw an axon terminal up here. We know that axon terminals release little vesicles full of acetylcholine. When that acetylcholine travels over to the neighboring muscle cell, acetylcholine binds to these sodium channels, and what happens to those sodium channels? They open. So as long as acetylcholine binds a sodium channel, then we have sodium that can come into that muscle cell. What happens to the muscle cell? It stays in a constant state of excitation. Well, that means that calcium is released from the SR, and myosin heads bind to actin filaments. So unfortunately, black widow spider toxin produces this effect of maintaining a state of tetanus. So that can cause problems like pneumonia to form in the lungs or other issues around the body where those muscles may stay in a locked state and unable to relax. So let's talk about Botox, because it performs a job that's actually opposite to what the black widow spider does. Botox is produced by a type of bacterium called botulinum. And botulinum is a toxin that can get into your muscles and prevent them from contracting at all. In other words, Botox promotes paralysis of the muscle. So let's talk about how that occurs. If you take a look at an axon terminal, and we know that vesicles full of ACH are released into the synaptic cleft between that and the neighboring muscle cell, then Botox actually prevents acetylcholine from being released here into that synaptic cleft. So if that's the case, and we think about these sodium channels here, there is not a way to open those sodium channels since ACH will not be able to bind and do its normal job. So we often see this injected in areas around the face for cosmetic purposes. It can even be used in the armpit area to reduce sweating. So Botox decreases acetylcholine release. Let's turn to page 89 and let me mention to you that recruitment of motor units is a second way for us to increase muscle tension. Keep in mind, there's two ways to increase muscle tension. One is through the increased frequency of stimulation, and two is by recruiting additional motor units. We know that a motor unit is the combination of a motor neuron and all of the skeletal muscles that it stimulates. If you end up using more motor units to do the job that you need, you can increase the tension. So let's talk about that in relation to doing a job like carrying a heavy box. If you carry a heavy box, maybe some china or some coin, something that has some weight to it, then your body may need to turn on more motor units to carry a really heavy box. Contrast that with how much work it is to carry a box of feathers. So the additional motor units help us to increase tension and do that extra job, that extra work. Interesting to note that if you've ever carried a really heavy box from point A to point B, sometimes you feel like, oh, I'm going to drop the box. Oh, this is too heavy. I'm going to have to put it down. You're sensing that the motor units are tiring and are not able to cycle on and off adequately to allow them to rest. Now, they do cycle on and off when you're doing a heavy workload, but you can exhaust them to the point that they can no longer manage that workload. And at that point, you may simply drop the box because you have exhausted all of your motor units. But normally, they will cycle on and off to avoid getting to that point of exhaustion. You can see here how one motor unit by itself can do a small load. 2 motor units can actually do a heavier duty workload, and 3 motor units continues to increase that tension and help us to lift or carry a heavier workload. So let's talk for a moment about slow twitch fibers and fast twitch fibers. You'll notice in this picture they take on 2 different colors. Slow twitch fibers are actually darker in color due to the storage of oxygen with myoglobin. Slow twitch fibers are ones that are endurance fibers. If you have to stand on your feet working a 12-hour shift, those are the muscles that do not ache at the end of the day. They're the ones that are supporting you during this long-term use of the muscle. Fast twitch fibers are ones that are lighter in color due to the lack of storage of myoglobin and the oxygen that goes with it. Fast twitch fibers do exactly as their name implies. They respond quickly and they have explosive amounts of power. Now, think about chickens for just a moment. We know that chickens have light meat and dark meat. The light-colored fibers are, in fact, fast twitch fibers. Think about a chicken. They don't often fly, but when they do, they need to fly quickly to get away from a predator. Slow twitch fibers are the dark meat on a chicken. This is where we find chicken leg meat, thigh meat, for instance, because that's what chickens do. They walk around the yard. So when we think about the speed of the fibers here, it's related to what those muscles really need to do. Now, in our bodies, we don't necessarily have light meat or dark meat. We actually have a combination of these fibers in most of our muscles. So if you're standing on your legs all day, it is the slow twitch fibers that support the endurance, while the fast twitch fibers respond quickly. All right, so let's take a look at atrophy and hypertrophy next. Hypertrophy means that a muscle has enlarged in size, perhaps due to exercise or repeated stimulation. Atrophy, however, is the opposite. It is the lack of muscle tone or muscle size, and this may result from simply wearing a cast or spending time in zero gravity space. Interesting to note that when people spend a considerable amount of time in outer space, they have to do exercises that keep their muscles toned. Otherwise, when they come back to Earth, their muscles have atrophied to the point that they can no longer support their body's weight. Imagine that, coming back to Earth weaker than when you left.